This is Geometry, Unit 7, Day 10. We're working with right triangle word problems. We have a high school student that's making a ramp for her brother's train for climbing. She knows the following dimensions of the ramp. She needs to find BC. So BC is the total length. AC, that's the total vertical height that it'll climb. And ED, that could be a brace that would be needed in the middle. So you can solve for any of those. It doesn't matter what order that we go in, but you have to set up your problem to be specifically solving for one of those. So let's solve for ED. So we have this small triangle. We have B, E, and D. We have a 20-degree angle. And we have a 9-inch long leg. So what we're trying to figure out is what DE, what is the height of DE. So we recognize that across from the 20 is the opposite side, next to the 20 is the adjacent side, and across from the 90 is the hypotenuse. So using the fact of SOHCAHTOA, which would help us determine which trig function that we should use, if we're trying to find the opposite side and we're given the adjacent, then we need to use the O and the A. That rules out sine. Cosine doesn't have O, doesn't have opposite, so that's out. O and A, that's tangent is opposite and adjacent. So we know that we're going to use tangent of 20, which should equal the opposite side over the adjacent side. Then we like to set this up as a proportion, cross multiply to give us 9 times the tangent of 20 equals ED. In this case, what we're solving for is already by itself, and using a calculator will come out to be 3.28, and that's the length of ED. When you're using a calculator, you need to be sure that it's in degree mode. The graphing calculators sometimes fall out of degree mode, so be sure that that stays in degree mode. Once you set that, it will always stay there until you reset your calculator. If you're using a phone, sometimes you have to put in the degree first and then tangent times 9, and you'll still get your answer of 3.28. So next, since we've solved for ED, let's solve for AC next. Here we have the bigger triangle. We're solving for AC. The long leg in this case is 23. We're solving for the short leg. So again, opposite and adjacent. So that's going to be the tangent of 20 degrees is going to be the opposite side over the adjacent side. So we put this over 1 to cross multiply. So that's 23 times tangent of 20, which equals AC. When we calculate what AC is, that comes out to be 8.37. Notice when picking your trig function that we were not dealing with hypotenuse. We didn't know it, and in this case we're not looking for it. So that rules out sine and that rules out cosine, so we have to pick tangent. Then you set up your fraction as the opposite over the adjacent, OA, opposite adjacent, and they make your fraction. The last one we're going to solve for is BC. Again, that's the larger triangle, B to C. we know that 23 is this long leg, 20 degrees is the angle. So next to the angle is the adjacent side. Solving for AC would be the opposite, and across from the 90 is the hypotenuse. Well, BC is across from the 90, so we need to deal with something that works with hypotenuse. And SOHCAHTOA tells us that adjacent over hypotenuse is cosine. So we're going to work with the cosine of 20 degrees, which is the adjacent over the hypotenuse. We put that over 1, because that allows us to set up a proportion that we can solve by cross multiplying. Notice in this case how the BC comes up next to the cosine of 20. It's whatever in the denominator is going to multiply what your trig function is. We want BC by itself, so we're going to have to turn back around and divide by the cosine of 20. That'll get BC all by itself to give us, using your calculator, 24/48. So if you wanted to bring in your calculator, in this case it would be 23 divided by the cosine of 20. Gives us 24/47/6, and because the 6 is 5 or bigger, it turns that into a 48. On the next side, we're looking at Jansen, who's decorating a cake for the geometry department. He thinks it would be fun to make a right triangle with an acute angle of 38 degrees and a short leg of 12 centimeters. So if we have 38 degrees, we know that that's going to be the smaller of the two acute angles. Together they have to add up to 90, and 38 is small compared to what the other angle would be. We'll talk about that next. The short leg has to be across from the shorter angle, so the 12 has to be across from the 38. That is the opposite side. The adjacent side is here, which could be called the long leg, and the hypotenuse is always across from the 90. So when we're going to try to solve, we can solve for either of the three information that we're looking for. It doesn't matter. Let's try to solve for the hypotenuse. So from the 38, opposite is the 12, the hypotenuse, opposite over hypotenuse, using the concept of SOHCAHTOA, you need to try to write that out for every problem to get yourself familiar with it. So opposite and hypotenuse is sine. That's what this S stands for, sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So sine of 38 equals the opposite over the hypotenuse. So again, we put our trig function over 1, cross multiply. The hypotenuse comes up next to your trig function. 1 times 12 is 12. Now we want the hypotenuse by itself, so we got to come back and divide by sine of 38. So the hypotenuse now, when we use your calculator and do 12 divided by the sine of 38, you're going to get 19/49. The other side that we want to solve for is the adjacent. 19/49 was the hypotenuse. I'd suggest not to use that information. If 19/49 was incorrect, then you're guaranteed to get the wrong answer with another side. Or because it's a rounded number, you're not doing an exact number, you're not going to really get an exact result. So let's use the 12. Let's use opposite and adjacent, which we can see is going to be tangent. The opposite is 12, the adjacent is our unknown. Put it over 1. Cross multiply. So the adjacent times the tangent of 38 is going to equal 12. Again, we have to divide by the tangent of 38. That'll get the adjacent all by itself. And we divide, we get 15.36. Now to calculate this last angle, the last acute angle. Well, we know that all three angles have to add up to 90. This is a right triangle, so that would show that the two acute angles have to be complementary. So you know that those two acute angles have to add up to 90 also. So we're going to get 52 degrees when we subtracted 38 from 90. For question number 3, we're looking at the properties of a rhombus. A rhombus is something that we know to have all sides the same, diagonals that are intersecting, they're bisecting each other. There's a lot of different properties that are true about a rhombus. What we need to identify is a rhombus a pentagon or a quadrilateral? So you need to know what these terms mean. Pentagon means it has 5 sides. Quadrilateral means that it has 4 sides. So of course, this has 4 sides. Is it a parallelogram or a trapezoid? Well, a trapezoid has 1 set of parallel sides. A parallelogram has 2 sets of parallel sides. There's 3 special types of trapezoids. Or, I'm sorry, 3 special types of parallelograms. A rectangle, a square, and a rhombus. So yes, this is a parallelogram. What do we know about these 4 sides? We've already discussed that they are congruent. So we can put our congruent marks on our shape. We also know that the opposite angles, these full opposite angles, are going to be congruent to each other. Not that all angles are the same, but the opposite ones have to be the same. That's true about all parallelograms. The 4 angles always add up to 360 degrees. That's true about every quadrilateral. The diagonals, in this case, they're intersecting at point H. They're made by the diagonals that bisect each other. How do these diagonals intersect? They're forming right angles. So we know those are right angles. We know that the diagonals are supposed to bisect. I'm going to put 2 tick marks because that would be different than what the side of the rhombus is. And then this side is going to be different than the other 2. But the diagonals bisect each other, meaning that on both sides of H, they're the same length. And on both sides going the other way, they're the same. When the diagonal comes into the angle, it bisects the opposite angles. So this one gets cut into 2 equal pieces, and it would do the same here. These are going to come out to be the same. So those are some common properties that we talk about with a rhombus. For number 4, you want to make an extra credit question for the class to solve. You decide to make one of the angles of a rhombus 57 and the shorter diagonal 14. So we have 57 degrees for a small angle, and the diagonal is 14 inches. So now we want to look to see how long will each side be, and how long is the other diagonal. Well, when we look at this, we don't have enough information just here for us to be solving for the sides and the diagonals. We don't even have the diagonal drawn. Remember that when you draw on a diagonal of a rhombus, it's going to be perpendicular to the other diagonal every time. So what that's going to do, that's going to make this right triangle. Remember that the diagonals bisect the opposite angle, so it bisects the 57. So that's going to turn into 23.5 degrees. The 14 also gets bisected. The diagonals bisect each other, so one part of that 14 is just going to be 7. So now we're going to try to figure out what the hypotenuse is. That's across from the 90. So we're dealing with the opposite side and the hypotenuse. So thinking about SOHCAHTOA, that's going to be sine of 23.5. The opposite is the 7, and the hypotenuse, which is the side of the trapezoid, side of the rhombus, is known as our hypotenuse. Put it over 1 so we can cross multiply. So the hypotenuse times the sine of 23.5 is supposed to equal 7. We'll have to turn around and divide because we want to get the hypotenuse by itself. And when we do that, we get 17.55 inches. The other question that we want to answer is how long is the other diagonal? The other diagonal goes all the way across, but we need to stay in just the right triangle so we can use our trigonometry. So remember that the diagonals bisect each other, so whatever answer we get for this long leg, we're going to have to times that by 2 to figure out the whole diagonal. So now we're looking for the side next to the 23.5, which is called the adjacent side. So now we're going to deal with opposite over adjacent. So we're working with tangent of 23.5. Putting tangent over 1, cross multiplying. So the adjacent side times the tangent of 23.5 equals 7. 7 times 1. We'll divide by the tangent of 23.5. That gets the adjacent side by itself, and we're going to come up with 16.09. Now remember that the diagonals bisect each other, so 16.09 is the long leg. The long diagonal is going to be 2 times 16.09. So that comes out to be 32.18. And of course that would be the same units as inches. Our last question. What would be the lengths of HS and CS? This question shows that the tangent of H equals 8 over 9. So the opposite over adjacent would have the same decimal version as 8 over 9. Now, that would be just fine, but they also show us that it's 42, and that wouldn't be consistent. If you notice here that the tangent of 42, which is 0.90040 and so forth, is a tad bit different than 8 divided by 9. So the tangent of 42 is not quite that. So something has to go. Either we throw out the tangent or we throw out the 42 and we could then go ahead and solve the problem. You use a little Pythagorean theorem really with this problem. But let's solve it not so much using the tangent of h, but let's use it with the concept of the 42. So the opposite side is across from it, the adjacent side is next to it, and the hypotenuse is across from the 90. So if we're going to solve for CS, that's going to be using the concept of SOHCAHTOA. Opposite hypotenuse, OH, that's sine. So sine of 42 equals the opposite over the hypotenuse. Cross multiply. And when we multiply those two together, we get 16.06. Now, if we're going to try to figure out the adjacent side, we still have the hypotenuse. I wouldn't use the value of CS because that's an approximate value. Let's use adjacent and hypotenuse. So adjacent hypotenuse is cosine. Cosine of 42 degrees is the adjacent side, which is HS over 24. Cross multiply. And we multiply that out, we get 17.84. So that is the HS and CS of our right triangle.